Hello, everybody, and welcome to June's Swarm's community call. Summer is here already, here in the North Hemisphere, of course, and we are broadcasting live to all the corners of the interweb. Then that includes streaming on X. So, hello there, and you're very welcome to join the conversation in Discord. Thank you for coming. My name's Antonio, and I'm very glad to be your host today, wherever you are within this pale blue dot. All right, let's kick in. And what can you expect of the call today? Here's the agenda. We will have core development updates with Callum and Lubisha. We will have a very interesting talk, long awaited talk in the community talk section that will be called Swarmonomics, a new research program launched for the token economics of BCC. Then we'll continue with another community talk where we will have amazing breakthrough changes you will see about performance and UX innovations by Etherna with Mirko da Corte. And finally, we'll conclude with our classic community AMA and open space for debate. So without further ado, let's begin. And we will begin with the core development updates. And for that, I would like to invite to stage Callum and Luisha. If you can raise your hand, please. There you go. I got you. I got you. And they will speak about, hopefully, they will speak about a B 2.6.0 that has been postponed during some testing and some results that that happened recently. Better safe than sorry. So, Callum, could you give us some light of all this development?
Yeah, hi Antonio. Hi everybody. Basically, it's been postponed, just like you say, to be better safe than sorry, and just to kind of really scrutinize our own kind of testing rigor, and with the primary principle being that the network must not in any way, shape, or form be compromised at all. And that's why we just postponed and released it. We don't feel that that's necessary, and I think in the wake of Ethereum updates and Sepolia in general, and our own testnet setup and configuration, it just seemed like the prudent thing to do was just to hold off and test a little bit further. And for any of the actual technical updates of where we were, what the problem was, what we're testing, and what's fixed now, I'd give that over to Labisha to go a little bit deeper.
Oh, so yeah, over the past few weeks, we had made some significant progress in improving the node spin up and transaction handling. Spin up improvement has reduced the time required to update peer status and significantly accelerating the node initialization and readiness. We also refined our transaction cost estimation process, and previously we relied on outdated methods that produced inaccurate estimates. Now we calculate costs based on the latest blocks base fee combined with the suggested tip, and this will enable us to develop more precise and reliable estimates. As mentioned on the release side, yeah, we did had delays. Those delays occurred because first of the transaction fee, and we wanted to allow node operators to participate in the redistribution game more fairly. Additionally, like significant updates to the node spin-up process, which now uses postage snapshot data, required us to improve our testing procedures to ensure absolute confidence in these changes, because those are really important details. So to strengthen our testing, we are working on a fully isolated testing cluster with dedicated smart contracts and isolated mainnet cluster to try to simulate future migration. These efforts will drive smoother updates and greater system stability. Also, we are actively refining our testing processes to improve reliability. But we are still setting milestones according to our priority. So our priorities for the next phase include further improving of our testing framework and updating the handshake protocol as proposed by MFW. We are also investigating how to implement fair TCP listener for the WebSocket protocol. Also, we plan to collect detailed metrics on the pulsing protocol to be able to estimate its performance. To further improve our testing coverage, we are evaluating which beekeeper checks can be refined to ensure better validation. And so those are some steps that we are doing in the next period. Also, I want to apologize MFW because we still haven't reviewed his PR, but it's on our radar, and I hope we'll do this as soon as possible. And that's it for me.
All right. Thank you so much, Lubisha and Callum. Very comprehensive. I think that a good testnet, it's fundamental to have a solid network. It's very, I can stress enough. Any efforts going in this direction will result in a better experience for everybody using Swarm. So good for that. I mean, they can go very far. We have previous examples, such as what happened with Kusama, that they even deployed a new token just for testing purposes. But it's as I said, it's very, very important to make the network reliable. Thank you so much. Thank you so much for this. And that was the part on the core development update. Please, Lubisha and Callum, stay with us if you.
Could I
All right.
potentially stay one more minute to just give a quick update on the more product side of our engineering, which is the
Of
multi-chain app?
course. Please be
Everyone's
my
interested
guest.
in, and then I'll not steal any more time or anyone's ears for any longer than I need to. Yeah, so equally on our other release schedules for more of the product related concerns, we've obviously got what's in the works internally, which is the multi-chain app, and then obviously externally we have the in-browser clients. Both of these applications put together creates basically this layer above Swarm in general as an infrastructure layer to be able to access it and use it much more simply without having to run your node yourself and know all the ins and outs and documentation to the full extent. So incredibly useful products. On our side of the fence, the multi-chain itself, we have everything complete that we need to have as a requirement to be able to release it. So you can rest assured that it is complete, and we have this under embargo basically until the right moment in time where we want to release it and we can get the right announcements, right PR, the right timing, essentially. But it is there, ready and free to test over at app.ethswarm.org. So you can go there, use it. We'd love the feedback. Put it in the Discord as well. And there's the last few kinks that we're ironing out in it, which are not even necessarily down to our product or our engineering. So all feedback is welcome. But obviously, what we're working on then, once we release it, we've got our roadmap of the nice to haves to come afterwards. That might be, ENS integrations, multiple file uploads, email reminders, disclaimers, more chains, Solana, etc., etc. So we have our full roadmap and pipeline of the features that are nice to have that we want to come next. But what we have is here, works, last few kinks, and a release date is all that matters. But it's here for you and everybody on this call to go and look at it, use it, and come back to it periodically over at app.ethswarm.org. Other than that, I'll be quiet. All right, cheers. Thanks very much, everybody. And Antonio.
Thank you so much, Callum. That was quite informative. Thank you. And please stay with us just in case something pops up. I would like to remind everybody that you can leave your comments on the stage chat, which is a different chat from the actual chat that you will have clicking on the top right icon, so that the questions will be answered even if the call is finished. Thank you, guys. And let's move on to our first community talk. This talk would be about Swarmonomics, that is, tokenomics from Swarm, a new research program launched in order to evolve and potentially improve the tokenomics that our current and beloved token has. Swarm is entering this new phase where the economy it's starting to matter really, really much because it's getting real, and real economies demand rigorous observation, modeling, and principled policy. So to meet the demand of transparency, because everything needs to be publicly showcased, and principled protocol design, Shtuka Research, and I love the name, will undertake a year-long program of econometric and mechanism design, the opposite of game theory, to support a robust, scalable swarm economy. I would like to welcome Andrew from Shtuka Research and Aata to take us through the plan. Hello, Andrew. Hello,
Hello,
Aata.
thanks for the invitation. I'm going to try to share my screen for a short presentation.
All right, I can see it.
Is visible now, full screen?
It is for me.
Okay, great. Well, probably for everybody else too. Oh dear. Yeah, so thanks for the intro, Antonio. I'm very excited to be embarking on this program. Just to repeat the intro a little bit, Shtuka Research, that's me and Aata, will be undertaking this year-long program, which we call Swarmonomics, as an external research contributor, and we'll be doing incentive mechanism and market design research and econometric studies with the aim of mapping out the swarm's economy and introducing principled approaches to protocol design and improvement. So far beyond tokenomics of the buzz token, we're also going to be looking at the structure of swarm's its internal economy, supply and demand, pricing mechanisms, that kind of thing. So here are some of the questions we're going to be thinking about. What does the competitive landscape of the Swarm node market look like? What do I, as a node operator or potential staker, need to know before entering this market? What kind of APY am I going to get? What kind of strategy should I use? Is the Swarm storage market liquid enough to respond to a big surge of demand that we all hope is coming from these wonderful new updates that are being made on the product end? How does the price quoting mechanism work? How well is it working? Is it responsive enough to signal that more or less supply is needed in responses to changes in demand? Are fluctuations in these prices or the buzz token price affecting demand by scaring off users? How well does the price oracle behave dynamically? Will it converge to something stable? Will it fly off to infinity or go down to zero, or will it wobble around wildly? And given answers to these questions, can devs do something? What are we going to do about it? What kind of improvements can we make? How can we make principled data-driven choices for protocol parameters? So how to engage? What is this going to produce? We'll be doing monthly updates shared in Discord's research channel. Some of you have already seen that we've shared the first update from May already, and then the next one for this month will be coming in a few days. As well as that, we'll be outputting various research notes, memos, and publishing a dashboard with data visualizations. And if you want to get in touch, just ping me or Aata in the Discord. Just anything you want to feedback or to discuss about some of these research topics or suggest other topics, let us know and we'll chat about it in the research channel.
Ethereum proof of stake handle similar issues, and you think this is the way that we should be, or the network should be considering, or should be some other ideas in terms of this resilience to volume changes?
Yeah, so I guess you could be talking about a number of things there. Some of the questions which apply to both Swarm and to Ethereum are related to the price quoting mechanism. And maybe is that what you were talking about? It's like Ethereum's base fee quoted in a similar way to
Exactly.
Swarm storage price controller. Yeah, so while of course Ethereum's research community has, is much larger, and there's been more work done on the dynamics of those the Ethereum EIP 1559 controller and its game theory. Actually, in terms of parameter choice, even Ethereum mainnet hasn't really had a proper study done to make decisions about how these parameters should be chosen. It's kind of a bit of a gap that's been acknowledged by some in the community. But there are certainly transferable ideas of things that have been done, such as sort of qualitative dynamical systems type studies of how the price controller operates. Formally, it's extremely similar to Swarm, and we're going to expect to be doing some work trying to transfer some of those ideas.
It's pretty cool.
As well as introducing new ones, trying to use data to actually suggest parameters such as the learning rate.
Learning rate.
Did this answer the elasticity question for you, though, Antonio?
Yeah, it does.
Okay, cool.
But I have another one, which is
Okay.
because I went through the GitHub and I couldn't help but to focus on the stablecoin design for stability, and I would like to ask which is a whole. It's a nice topic, and I would like to ask you, when thinking about stablecoins, do you think it should be collateral based, it should be market based, or it should be algorithm? It's the three types of stablecoins that are around. Which one do you think will resonate more with Swarm?
I think this is not something that you can even produce a collateral for. You can't really back this as some type of battery, but it should be something that is, I guess in a sense, it's algorithmic, right? You should be able to trade, you should be able to redeem that stable coin for some number of bytes per epoch.
Hold on a minute, guys. Can I just make sure we're all talking about the same thing here? Are you talking about, Antonio, you're asking about the storage stablecoin idea?
Yeah.
Yeah, let's make sure. Okay.
Yeah. Fine, carry on.
Yeah. I think this should, like, if we're talking about like Swarm in particular, yeah, this should be like about the number of chunks per a chunk block. A stable coin should be linked to the chunk block.
Interesting.
This is the
Okay,
idea. It's not more complex than that.
I'd say to clarify in terms of the roadmap for this project, the storage stablecoin is kind of more of a long-range research idea, and there are many more things to work out, and we're expecting to get around to tackling that in the latter half of the project. So
Awesome.
at this point,
Yeah, it's okay.
please take everything I have to say about it right now as sort of at the ideation stage.
Of
course.
Right now, I would say it's a thought experiment, but I do think there are very concrete questions to work out, and that is part of what is Swarmonomics.
Awesome. I just wanted to tease you guys. Thank you for that. No worries about that. It's not going to be carved on stone what you just said. It will be recorded, and it's great to have someone thinking on this, which is a long-term plan for Swarm, and it's part of the world domination roadmap. So thanks a lot.
Thanks
Nice
a lot. Questions.
Thank you, guys. Thank you for this. And please stay with us just in case someone pops up with some more questions. And that's it. And thank you. I will slightly but firmly move you to audience, but I will keep an eye on you over there. Thank you. We will keep on with our community talks, and then we will speak. Now we will speaking about performance, client performance, and UX innovations. And to talk about this, I would like to invite Mirko towards us. I think that what Mirko is about to present is going to resonate very much with the builders in the room that comes from the .NET world, because we'll hear about BNet, which is a Swarm client built entirely in C++. There are high performance primitives running on .NET with impressive speed gains. And second, we'll take a look at Beehive, which is a browser-based dashboard that has implemented some UX improvements. But not without further ado, and not to tell you more, please welcome Mirko da Corte.
Hello everyone. Thank you very much. I will try to share my screen now.
Good luck.
Yes. Next. Okay. Can you see it?
2 out of 2. This is amazing. I am so happy today. Yes,
Yeah.
we can see it.
Perfect. You confirm you see the presentation?
I do. I do.
Yeah, great. So today I will present the research performed by Etherna in last month. And I will present our research in the context of the two projects, B.NET and Beehive. And I will perform a rapid overview over all the points. So starting with B.NET, B.NET is become what I say a Swarm development kit built with C# for the .NET framework, and is published open source with LGPL on GitHub. It is composed by is a collection of libraries published on NuGet. And each library is focused on a scope. We have a core that contains all the logic. On the core logic, we have a client that implements specifically connection client for B, and we have a library to integrate better the core with specifically the ASP.NET environment. And what I'm going to show you with B.NET will be ported also on native browser with WASM. We are working on it, but still not ready, but will arrive. So what is B.NET today? This is an internal framework that evolved in time. At start, it was only a client for B, but it now integrates also high-performance object-oriented Swarm primitives that is integrated in all the code base. And with these primitives, we focused also on development of several abstraction to use these primitives, like a chunk store interface with several implementation based on the actual storage support for chunks. That is any application can implement its chunk store version. We have implemented a full hashing pipeline compatible obviously with hashing from B. And this hashing pipeline supports also partial input streams. That is a specific case when the input is not always received complete. So, for example, when we push some data with HTTP. And supports also the feature that we will explain later, that is chunks compaction. We have implemented also a postage stamper with already supporting pre-signed stamps. It also supports manta ray manifest manipulation and reading from any kind of chunk store, so to publish or read any kind of contents. We have implemented also feeds with sequential and epochs. So also these are supported in reading and writing. We have implemented also an high-performance chunk data stream that I will go more in deep later, with supports to range readings and seek support. We have implemented with B.NET also a chunk traverser, useful, for example, when we want to traverse a tree of chunks, for example, for pinning scope. And we have added also some useful utility services to manage complex uploads like a directory, like file, and some helpful primitives like converters, serializers to integrate with the .NET framework itself. The first innovation that I want to present you is our hashing speed improvements that we have implemented with this library. And we have performed some tests with it for have a fair comparison between B and B.NET. The time capture has been done in code, so we will not have any overheads about network communication. And for the instance, I can show you also the exactly code changes that I made to measure the timing around the hashing function. And we have disabled also the chunk storage stage because this is not useful to measure the only hash, the pure hashing function timing. And so I removed for the test this code. The code has been run on my notebook with 16 CPU core and 64 GB of RAMs. And each time has been performed on random files of 10 gigabytes. And I'm measuring B, the last public version of B versus the last public version of B.NET. So the result shows that the average speed of hashing with B with files of 10 gigabytes is around 2 minutes, 121 seconds. Instead, our B.NET can hash the same files in 35 seconds in average. And this leads to an average speed improvement of 3.4 faster for B.NET against B. That I think is a good result. This has been possible with several optimizations our side. The first one, the most important probably, is a parallelization of chunks hashing with all CPU cores. And we have performed also a low-level memory optimization using some high-performance primitives exposed by .NET that allow to work with array segments without need to copy memory. Obviously, we are going to reuse as much as possible of the data structure, and we also have implemented an optimistic hashing algorithm that I will show is required for porting all this optimization with the feature of chunks compaction. Anyway, with next version, I suppose we can also improve even more this speed result. The chunk compaction that I already presented in previous version on some talks ago has evolved and basically I will introduce you again is an operation of mining on chunks to try to uniformize chunk hashes with a given postage bucket with a given status that can be any. Advantages of performed chunks compaction are multiple. One of these is that producing more uniform hashes can distribute better chunks to nodes. And another advantage is the actual cost reduction, because lowering the required depth for the same postage batch tends to use the full postage batch for its maximal theoretical volume limit. This chunks compaction has been performed in different ways based on the chunk type. In the case of a mandatory node chunk, we already have an implementation of the obfuscation key, and we will use it. That changing the key will change the final hash. Instead, so with the mandatory, we can keep retrocompatibility with B. Instead, with the intermediate and data chunks, we are going to introduce the new recursive encryption that will be need to be integrated also in B to be compatible with optimized compacted chunks. Instead, in case of single overhead chunks, we can't apply by design this optimization because of how single overhead chunks works. So we will ignore them. The specification of chunks compaction is very simple. We have introduced a new parameter that is the compact level in a range of between 0 and to elevated 16. So we have chosen the same range of buckets indexes, and by default for compatibility with B the value is 0 if nothing is passed. What this index mean? It indicates how many keys we want to test at maximum, trying to find the first best fitting chunk. This doesn't mean we will try all of the tests for the compact level specified, because we can stop also earlier with if we find a best fitting chunk, but this is the maximum value. And the first best chunk is the chunk that we can fit in a bucket with the lowest possible number of already present collisions. The second specification that we required is that the execution must be deterministic. So what it means? It means that with the same input and the same status of postage buckets, the final hash must be the same. Where we will save these keys, encryption keys used to compact chunks. In the manta ray node, as I said, is simple because we will use the obfuscation key, so it's already contained with the manta ray node by protocol. Instead, if we are trying to compact a BMT route, so probably an intermediate chunks, we will keep the metadata with the manta ray node itself linking to it. So we have introduced two new metadata. One is a recursive encryption that is a Boolean value when it is true. It's false by default, but if it's true, this means that intermediate chunks must be interpreted not as a simple sequence of reference hashes, but a sequence of couples composed by an hash and an encryption key. So instead of 128 references, each intermediate chunks will be able to contain only 64 references, but encrypted. And we have introduced the metadata chunk encrypt key to contain the effectively root encryption key. If the chance compacting is applied not on a BMT root. As I said, we have to look at the parent intermediate chunk with the pair hash and key. What we found about cost reductions with chunks compaction by our test, as I already published on the B issue on GitHub, we have found a cost reduction of 8 times, passing, for example, with these tests from an average required depth of 20 to an average required depth of 16. And we have noticed that we have best results when we get near of 2 elevated n with the number of chunks. So in this case, the required compaction level will be higher, but also gain is better. What we have found integrating these optimizations about performance and about the chunks compaction is an apparent conflict of interest in the hashing pipeline, because the parallel chunk hashing is required by performance, and obviously parallel hashing operation have concurrent access to buckets for insertion, but deterministic execution for chunk compaction instead requires an ordered insertion into buckets. And we have found a solution for this, and the solution is using an optimistic BMT hashing algorithm. And we can do this because we have found that the master EV operation is the actual hashing that anyway needs to be performed several times with chunks compaction, and we can do this optimistically in parallel. And then we can halt the process, waiting for the previous chunk that has been inserted in the buckets. When the previous one has been inserted, we can verify if the collision on the selected bucket optimistically is changed or not. And if it's not, because the inserting operation can only add a new bucket. If the found one was the first best chunk, we already know that this condition didn't change, so we can proceed with the complexity of O of 1. In the case instead of the optimistic algorithm is so the collision of the selected bucket changed, we can simply repeat the search, but using again the results, the hashing result that has been cached with the previous operation. So anyway, the second time will be very faster. And in the case, only new hashes must be computed. So anyway, we keep an high performance also in this case. Another operation that we've improved with B.NET is how we compose the data stream reading from a tree of chunks. And if we see how this is been implemented in B, we can find that each chunk is read once at a time and in pre-order with three of chunks. So at first the root is written, then the first intermediate chunk in the case of reading starting from the byte 0. And recursively, we go down until the data, and we proceed with the recursion one chunk at time. And this is very time expensive because in the optimal chunk store assesses case, with n chunks, the complexity is O of n. And we decided to improve this in the case of the chunk store supports bulk reads. And because we have abstracted this, the chunk store, we don't know before if the store will support bulks read or parallel reads. And we have some cases where this is true. So what we do instead is reading chunks in bulks by layer. So we start from root, and from root we calculate where the range that we are trying to read recedes. So we get the full layer or the segment layer, calculating the left bound that we don't need and the right bound that we don't need, receiving only the chunks that we need for the requested range. And then we proceed to the end, reading only necessary chunks, but one with a single reads by layer. And this can reduce a lot the access time because now with n chunks, complexity is O of the high, or in function of n is O of logarithm of n with the base 128. That's a much lower the read assesses. This is very useful, for example, when the chunk store can parallelize the reads, for example, when the reads are performed over the network, or when the chunk store is implemented with a database. For example, the application later that we'll present. If the chunk store only supports sequence reads, nothing changes and the performance are the same. This new method supports range requests, support data seek, supports partial layer accesses, and also implements remaining layer caching that allow to not read again the same layer if the reading stream access layers with a buffer smaller than the requested part. What we already have read once, we will not read again, and this optimize even more the performance. The second project that I want to show you is Beehive. This is a new project never seen before. Is a Swarm meta node with local storage on database. Has been built on top of B.NET and is now in alpha stage, published open source with a GPL license. What is Beehive? Beehive is a scalable meta node with the high availability support in mind. So every component is fileable and can be replaced pretty easily. It tries to keep B compatibility everywhere is possible. and introduce some improved APIs out of the box when compatibility is not possible. It uses an array of Swarm B nodes to communicate with the Swarm network, and already perform itself data hashing and chunks production, storing them on instance of MongoDB, implementing also pinning on it. This is highly scalable because each component is independent. Beehive itself is stateless, so I can rise or destroy instances in any moment. Instead, B nodes are stateful, but I can add from 1 to n without any problem. And MongoDB implements its own scalability with replica sets, shards, etc. What you have implemented with Beehive APIs is three kind of different APIs. We have full B compatible APIs whenever it is possible. These could have been improved with not breaking changes, but we have also implemented other experimental or Etherna Swarm APIs with a new prefix, versioned prefix EV1 that to separate from the Swarm versioning of V1. And the idea of these experimental or Etherna APIs is that we feel free to experiment on this, and if and when also the official B client will integrate them, we can deprecate our version and move to the new implementation, or we can proceed with our versions without problems. And the third kind of APIs are specific to Beehive, for example, reading the list of connected B nodes, and this is specific to this kind of application. What we have introduced to APIs, relevant changes. The Bytes API now supports compacted chunks, both with upload and downloads, and they remains full compatible with B. BZZ the same, introduce support to compact chunks, and also is able now to resolve epoch feeds. We have introduced a new API additionally to the previous one from B for chunks to allow bulks uploads. Sorry. Bulk uploads permits to use the full bandwidth of the network connection, allowing to send bulk a lot of chunks altogether, and this eliminates the overhead of sending one chunk by time. This improves a lot also over the WebSocket version, and I performed some tests with 100 or even more of performance gain. With Feeds API, we have implemented epoch feeds. We support compacted chunks with the feed manifest, obviously not with single overhead chunks, as I said, full back compatible with B. And with pinning, we are trying to evolve in this, introducing asynchronous pinning to not have to make clients wait for the operation to finish. We support also partial pinning results, where a pinning could fail to find some chunks, but this could be recovered later in the case. And We support recursively encrypted chunks with the chunk traverser, and we have added also pinning of single owner chunks that was missing from the B APIs. With our research, we have also identified protocol vulnerability about single owner chunks, in our opinion, because by design, each single owner chunks is recognizable from content addressed chunks, and in this way, any node can sniff all of them, passing hit. But what we have found is that by protocol, very often single owner chunks contains references or embedded chunks of root manta ray nodes. And this is a problem because by feeds protocol, these root nodes are always in clear. And this means that sniffing all single owner chunks, each node can have a perfect knowledge of the contents linked with these root chunks. And this is obviously is a vulnerability because permits to everyone to de-anonymize contents directly or indirectly linked by single owner chunks. We have found a solution on this, but the solution can't be to encrypt the single owner chunks because how these are designed. So what we have found is that we can encrypt by default all the single owner chunk contents, so the reference to the chunk or the embedded chunk. And we can encrypt the content with a self-generated key when we want to upload SOC content, or we can accept a custom key from a user. We can also have a constant key in the case of the feed. And in this specific case, could be easy to store the SOC key into the feed manifest itself to allow a simple feed resolution as before with BZZ. What we have found is that probably the XOR encryption is not a good encryption in this case because manta rays tends to have a common pattern of initial bytes. So this would lead to an easier key scan attack, not the full key space, but more focused. And probably another encryption method will be tested, maybe AES. Anyway, with the next versions of Beehive, we'll provide a fix for this issue with the new APIs. And I'm going to add a bonus slide on this presentation announcing that we are going to release soon our Swarm as a Service gateway. So to everyone that is developing over Swarm and needs some access to the network can contact us at this mail or me personally. And I want to note that Etherna research is self-funded since 2019, and we are always looking for investor or partners to help our research and development. Thank you very much, and this is all by me.
That was fantastic. Swarm as a Service gateway. Thank you. That's looking forward to test it. Thanks a lot. Mirko.
Thank you.
There's a comment, however, about what you said about SOCs. I just would like to voice it out here, that it says yes, about the fact that most chunks are encrypted by default, and they could contain some meaningful data in plain text. But they said, he said, socks are signed with arbitrary private keys, not the node's key. So while this is a clever strategy for finding data, it doesn't actually reveal who uploaded it or which node it came from. So
I've studied the source code of Beard and found that the Manta-Ray node is published in clear, and when is read from BZZ is in clear. I could perform a better research, but anyway, if a fix will come, will be later. So
all right.
I will perform more research, but this is what I found at now.
Fantastic. Okay, thanks a lot, Mirko. Thank you very
to
much
you.
for your comprehensive presentation.
Thank you. Thank you.
And let's move on to the last part of the call, which is Q&A. For the Q&A, we have been formulated a lot of questions all about the token. And well, I would like to just to answer all of them with because the questions are, well, is about the price, when token moon, why nobody not the team is not doing anything for the token? Well, if you stayed here for the whole call, you would have heard how there's this research going on to find out how effective the price oracle is at controlling replication date, how to improve transparency and lower the barrier of entry for node operators, how the demand responds to BCC and USDT volatility. Even a storage stablecoin that would unlock elastic, easily scalable cloud storage. So, well, for the financials over there, that's the ability to create solid futures instruments. So I would say it's in the way, give it some time, and the fruits will be born. And that takes us to the last part of our call with 1 hour straight. That's fantastic. If nobody has anything else to say, thank you. And I'm looking at you virtually. Mina? No, that's it. So thank you so much. Thank you very much to the speakers, presenters, and participants of the call. It was great to hear your voice or your keyboard taps. And of course, thank you, the audience. We are all Swarm. Speak freely.